Get ready for some time-saving tips and tricks as we quickly prototype an ice drill. In this tutorial, we'll prioritize speed as we create a concept for an ice drill. Instead of focusing on fully constraining sketches, selecting materials, or refining joints and components, we'll streamline the process for fast concept development. While these details are essential for production-ready designs, they aren't our focus today. We'll start by building the core structure of the drill's middle section. Follow along as we dive into the next step. When designing a helix, you have a lot of creative freedom. While there are plugins available, in this tutorial we'll focus on manually modeling the helix. The sketch lines you create form the foundation of your helix. And as with all parametric modeling in Autodesk Fusion, you can easily adjust the sketch later and your 3D model will update automatically. So, don't stress about getting it perfect on the first try. Refinements can always be made as you go. Don't be intimidated by the Surface Modeling tab. Once you start combining solid modeling, surface modeling, and form modeling, you unlock a lot of creative potential. The distance parameter is key because it lets you control how much of the profile you want to use. And the twist angle is a powerful tool to shape your design. You can even enter formulas in these fields for more precise control. Don't worry about the thin design at this stage. We'll address that later on. This is the section where the ice drill will be held. I'm going to make the first design iteration a bit unconventional, so we can see how easy it is to go back and make changes, and also explore some minor obstacles that might come up along the way. You can quickly move between input boxes using the tab key, and Fusion assists your design by automatically applying constraints. Most of the time, these constraints are helpful, but keep in mind Fusion can't read your mind. If any constraints don't fit your needs, simply delete them. Our sketch can be easily modified using the Fusion timeline, but if you're having trouble adjusting dimensions or moving lines, it's likely due to constraints. These are rules that define how the sketch geometry behaves. Fortunately, in Fusion, you can always tweak or remove constraints when they're not working for you. By combining constraint edits, adding new lines, and refining existing geometry with tools like fillet and trim, you can quickly make progress. And mastering keyboard shortcuts will speed things up, making 3D modeling in Fusion fast and efficient. In Autodesk Fusion, offset planes are a fantastic tool when you need to create a new sketch surface. For this concept, ice drill will place the sketch surface with a quick estimate without focusing on precise technical requirements. In a real-world design, you'd account for pressure in this area when operating the ice drill and develop a more detailed solution for fitting the parts together. You'll notice familiar sweep details in this step. For now, using the full distance without adding a twist angle will work well for this new body operation. Autodesk Fusion makes it easy to iterate and refine these kinds of designs as needed later on. Let's explore how to create a fun grip using the revolve command in Autodesk Fusion. This is a great chance to refine your design if you're happy with the initial concept. When working on a project, it's useful to think beyond individual commands and start combining them into workflows. For example, what happens when you start with a sketch, apply a rectangular pattern, and then add revolve, fillet, and copy rotate commands? The design process becomes much clearer when you think several steps ahead and plan how these tools can work together. While our first draft of the grip may not be perfect, it's a good starting point. Autodesk Fusion allows you to easily revisit and improve your design over time. By learning how to combine tools effectively, students can speed up the process and get creative with their design solutions, making their workflow more efficient and innovative. This approach is especially valuable in any Autodesk Fusion project for students, as it builds strong foundational skills for 3D modeling. Fusion offers several flexible options for copying and moving solid bodies. Be sure to validate your pivot point and check the Create Copy checkbox before finalizing your copy workflow. This method is quick and efficient for now, but what would you prioritize as the next step? Personally, even though speed is important, I see an issue with having two separate bodies, so I'd prefer to combine them. This way, we can improve the overall quality without sacrificing time. We're going to combine body 4 and body 5 to create a new component. Be sure to select the correct operation type so you don't accidentally cut away one of the bodies. Once combined, the new component will instantly appear in your project browser, ready for further adjustments. A well-structured assembly isn't the focus for this fast-paced draft, but I'll use the joint command to position a copy of our grip further down the ice drill. The copied component appears in the project browser with a clear logical name, making it easy to snap the joint into different positions. For now, the steel part of the ice drill intersects with the grip, but we'll leave it as is. There are still many questions to consider. Do we want grips this size? Is this the right shape? And should the helix look like this? We'll need to answer these before diving into the finer details. We'll use the thicken command to give the helix more depth. While I'm not entirely sure what the optimal design for the bottom part of the helix should be, it's a great opportunity to experiment. Try using the chamfer tool to explore different design options and see what works best. If you need to quickly switch between different stages of your design, remember that Ctrl+Z is your go-to for undoing actions, and Ctrl+Y allows you to redo them. This will help you toggle between changes quickly and efficiently as you refine your design. A sharp end will make it easier for the ice drill to penetrate the ice. You can achieve this by creating a simple sketch and combining it with an extruded circle with a taper angle to form a cone. Once joined with the other parts, it becomes one solid piece. It's helpful to toggle off the visibility of other objects to ensure you have a clear view of what your join operation is connecting. Our helix is starting to take shape, but there are still a few important workflows we need to cover to complete the design. Looks matter, and enhancing appearances can be fun. Did you know you can choose whether to apply appearances to entire bodies, components, or just specific faces? This flexibility helps you customize the visual style of your design. Another way to improve the appearance is by adjusting to visual style, which can make your design stand out. As you refine the look, you might notice something off with the top grip. Can you spot the issue? Take a moment to think about it before we go ahead and fix it. The issue with the handlebar grip is straightforward. I accidentally saved the body when we created the component. No problem though. We'll toggle the visibility before entering the rendering environment. A little knowledge of the rendering environment can go a long way. It's easy to combine different environments with the right settings, and it's quite enjoyable to watch how the shadows and lighting come together. It's tempting to overdo it because it's so fun, but my advice is to start rendering early. That way, you can quickly see what the final image will look like and make adjustments as needed. Once you have your initial rendering, you can iterate on it, making tweaks until you achieve the perfect result. I regularly post time-saving Autodesk Fusion tutorials on my channel, and I hope to see you again in a future project. If you're looking for more inspiration, check out my playlist with other Autodesk Fusion projects for students. Happy 3D modeling, and thank you for watching.